Good evening, everyone. I am Rakhi Yadav, your PMRF teaching assistant for Introductory Organic Chemistry course, which is conducted by NPTEL, whose course instructors are Professor Harinath Chakrapani and Professor Neeraja Dashaputre from ISER Pune. So, in week 7, students, we are going to cover problems which are based on name reaction in organic chemistry. We know there are various reactions which are associated with carbonyl chemistry, as we have studied aldol reaction, Cannizzaro reaction, ester condensation. So in this class, I have gathered all these name reactions along with their problems related to them, and let's start. So this is problem number 1 for this session. Draw the product formed in each of the following directed aldol reaction. You have to tell me product which can be formed in this aldol reaction. We know that when enolate when enolate of aldehyde or ketone attacks on carbonyl carbon of same or another aldehyde or ketone forms beta hydroxyketone as a product. That reaction is known as aldol reaction. Okay. So in first question, there is possibility for if we draw its hydrogen, we can see that there are two hydrogen which can be abstracted by base. You should know that LDA is lithium diisopropyl amide. If I draw its structure, it looks like this. From structure, from structure we may see that this is very bulky base. Okay, but if we look at temperature is minus 78 degree Celsius. It is very low temperature. So in chemistry, there are two types of enolate: thermodynamic enolate, kinetic enolate. At, these are favored at RT or high temperature, while kinetic enolate are formed at low temperature. So in first question, problem number A, this is its thermodynamic enolate, correct? And uh, this is its kinetic enolate. Okay. Since we are given bulkier base, which is LDA in our case, and temperature is very low, so it will form your kinetic enolate. Oxygen charge will come here and it is going to attack this cyclohexane carbonyl. Okay, what it is going to form? C double bond O, and this is a nucleophilic carbon. Let me change color of this pen. So it is going to attack to your right. This part came from your cyclohexane carbonaldehyde, and since workup is given H3, so it will form this beta hydroxy. Since heat is not given, no H plus source is there, so we don't have to form any alpha beta unsaturated product. So for A, this is our final product. Okay. In this case, LDA, it will directly abstract proton from here and it will attack on this carbonyl atom or carbonyl carbon. So this is product for your problem number B. And for this question, LDA, it will abstract proton from here, attack here, and C 1 2 and CH2 CO2 ET. So this is product in case C. So basically you just have to see condition which are given. So whenever you are given bulkier base, temperature is low, directly make first kinetic enolate. Okay. And if bases are like this sodium hydroxide, sodium ethoxide, then you have to form thermodynamic enolate. And then just you have to attack whatever electrophile is given in your question. Another take home message from this slide is you have to draw only aldol product here, not that aldol condensation product, because neither heat is given nor H plus H2 condition is given at last step. Okay. So I hope I'm clear. This I kept for you. As we can see that uh, your question may be what are these kinetic enolate and thermodynamic enolate. Okay. See, kinetic means product which is formed instantaneously without seeing anything, whether the formed enolate will be stable or not stable. Kinetic is instant. So, if we look at this unsymmetrical ketone, we can see that at left side or blue side, steric hindrance is less. Steric is less. So obviously, bulky base like diisopropylamide are going to abstract proton from this side. Therefore, kinetic enolate have been formed. But if we look at features of these enolate, we can observe that in kinetic enolate, less substituted double bond get formed. Okay. but it is less thermodynamically stable, because if we look at hyperconjugation of these two, or we can say that this right side enolate is more substituted one, while this is less substituted double bond. Therefore, and we know in chemistry, more substituted double bond is thermodynamically more stable. Why it is formed faster? Faster due to less steric hindrance at alpha carbon. Okay. So if you want to make thermodynamic enolate, you have to give RT temperature or very high temperature, and you have to use relatively lighter base. Okay. LDA comes under category of bulkier base. So this is diagram. If we look at stability wise, see, you can see that this thermodynamic enolate is in energy diagram, it is coming lower than this kinetic. This means thermodynamic, this is more stable relative to this left side enolate. Correct? I hope you understood till here, right? So this is kinetic enolate. There is a, we can't exactly measure, but we can see that this much difference in energy is there, which determine equilibrium ratio of these two enolates formed. Why there is higher barrier? Due to greater steric hindrance of hydrogen on right side. Okay, and here there is less steric hindrance. Here it is methyl, therefore steric. But if enolate is forming from left side, it is forming less stable enolate, but kinetically more stable. Remember, let me write a common statement: product formed in hurry, kinetic product. Product formed slowly, thermodynamic. Understood? So let's move ahead. So this is your HSAB principle. As per HSAB principle, hard acid should react with hard base and soft acid should react with soft base. Okay. For example, you have this center. Okay. Here two types of charge can generate. This one. Correct. There is one delta positive here and one delta positive here. And we all very well know that this center is relatively more, sorry for this center is relatively more electrophilic. So more electron density or more electron deficiency. They are hard acid. Sorry, they are hard acid and they are hard base. Correct? So if you look at this center is your soft, this center is hard. hard center, soft center. And you should know that there are three types of Grignard, we can't say, but there are three types of yes, correct term is organometallic reagents. First one is your Grignard, alkyl lithium. Third one is your organocuprates. You should remember the fact that Grignard and aldehyde alkyl lithium gives 1,2 addition, while organocuprate gives 1,4 addition. Why? Can anyone tell me? You should know that cuprates are relatively softer nucleophiles. So they will attack on this position, while organolithium and grignard will attack on this position. So this is take home message from this slide, and you may see that some nucleophiles, small charge, OH negative, ROF negative, these all come under hard nucleophiles. Soft nucleophile, soft nucleophile means largely diffused. For example, here this anion is largely diffused among iodine atoms. Correct? One more example is organocuprates. Soft example, मतलब soft nucleophiles. Correct? So this is your Michael reaction. So we will start in 1 minute. Wait. So yeah, let's start. First of all, before studying Michael reaction, you should know in Michael reaction there are two terminologies. One is your Michael donor and another is your Michael acceptor. Exact correct? If remember this thing, in alpha beta saturated system, your double bond should be conjugated with any electron withdrawing moiety, and this comes under your, let me change color here, this comes under your Michael acceptor. Correct? And this enolate, enolate comes under Michael donor, because whosoever is going to donate will come under donor category. Understood? So starting materials are your active methylene. This is your active methylene, right? Whenever CH2 group is sandwiched between two electron withdrawing groups, that moiety is known as your active methylene moiety. And this is your alpha beta unsaturated ketone. So let's see its mechanism. Hmm. So here what is happening? You may see that first base like sodium ethoxide is going to abstract proton from here. Correct? This will form enolate. This O negative will come back, and this carbanion formed here is going to attack in 1,4 fashion. correct? And we will get this entity. At last, base will come back and it will protonate here, and you will get this Michael adduct. Does anyone have any problem in this mechanism? Now, one would think, or one would say, why can't one do addition? So let's form both the product, correct? Let's say another, let's see another possibility. Okay, there, let's say this ketone is there. Let's say it is directly attacking at 1 2 position. Okay, so what it you will get, ETO CO CO2 ET, correct? And you will get O negative CH3. You will get adduct like this, correct? And here you are getting this. So can anyone tell me why this is more stable? Because if we look at it, final product, what we will get, let's draw its final product, CO2 ET, CO2 ET, and your OH, this, correct? And let's say here hydrogen is also there. Let's say it form this one. In with respect to this molecule is more stable, correct? Another thing is in this adduct, wait, in this adduct, every atom has full configuration. Wait, yes. So if we look at this structure, first of all, this is more stable adduct than with respect to this. Okay, and our final product is also relatively more stable than this. Therefore, remember always in Michael reaction, you have to do 1,4 addition. Let's revise this reaction again. Michael reaction have two types of terminologies or two components. One is your Michael donor, another is your Michael acceptor. Michael acceptor are having alpha beta unsaturated aldehyde, ketone, or any your olefin group should be in conjugation with your electron withdrawing group. That will behave as your Michael acceptor. And this active methylene, wait, let me use pointer here. And this active methylene is your Michael donor. Okay. So first enolate will form. From which side enolate will form? Obviously from ketone side. Okay, so it will form here. In both cases there are esters. Example is of another moiety, and I have given mechanism for other moiety, so don't get confused here. So this is your Michael donor. First enolate will form. It will attack in 1,4 fashion, form this adduct, and at last protonation will lead to this Michael adduct. Okay. So based on Michael reaction, I have kept 2 to 3 problems. So first, or our problem is, for this session, problem number 2 is, which of the following does not undergo an addition reaction with butane amine? Addition is nothing but your Michael addition. This is your Michael addition. Butanamine क्या what is your butanamine? This system, correct? We know this is your nucleophile, and we also know very well that in Michael reaction we should have two things: Michael donor and another is Michael acceptor, correct? So they are asking that they are having Michael donor, right? Because it is having lone pair. But where is Michael acceptor? This can behave as Michael acceptor, this can, but this is your nucleophile, this is your enamine. So two nucleophiles can't react with each other. Opposite attracts in organic chemistry too. So therefore, they are asking which of the following does not undergo. So option D is most appropriate option. Okay. So this is problem number 3. The following sequence shows a synthesis of cyclohex 2-enone. Okay. Which combination of reagents is feasible for carrying out steps 1 and step 2? Okay, students. In first step, they are let's do one by all option. Okay. In first step, they have given Br2, sodium hydroxide, and water. Okay, let's do one by one. See, sodium hydroxide and water are there along with Br2. So if sodium hydroxide is there, we have to form enolate, correct? Whenever you write anion, please write counter cation there. Okay. We know Br2 is there in medium. So oxygen charge will come here, attack on this and will form this, correct? In second step, it is given that it is given H2SO4 H2O and H2SO4 H2O can, मतलब, how can it react? Can anyone tell me? Let's say it is given H2SO4 and H2, right? What will happen? It will form H3 positive, and another thing is HSO4 negative. Basically, it's hydration in presence of acidic medium. So it can't elimination can't take place in this molecule. Correct? Correct or not? Sorry, this is BR. So option A can't be correct. Now option B, let's look at possibility. It is given HBr. See, HBr is given and acetic acid is also given. So can anyone think or tell me which is more acidic among HBr and your acetic acid? Basically, we know that HBr is more acidic, correct? So it is going to protonate this, and now we have two competing nucleophile in our medium. One is your acetic acid, okay, or we can say that acetyl ion, and another is your Br negative. So we can't get this multi. So these two option gets eliminated. Last option is your, let me draw its mechanism in stepwise manner. First, in presence of acetic acid, your carbonyl gets protonated. Correct? Now, after protonation, it will this acetic acid has become OAC negative. Now it will abstract proton from here and it will form enol. What it will form? Enol. Correct? And then this O negative lone pair of oxygen will come back and going to attack your Br, and it will result in formation of this. Correct? In next step, base is given. So base will do what? Fast students. Base is going to abstract proton from here. It will go there and it will knock off your bromine and will result into formation of this cyclohexenone. Problem number 4. Which of the following reaction shows a wrong main product? So I have told you in slide number 3, I think, that Grignard gives 1 2 addition. Correct? So on 1 2 addition, let's draw what product will form. I have drawn it wrong. Wait. You can write Grignard like this. Okay. So this is going to do 1 2 attack. O negative and MgBr. For now, you can see that here. You will get this, and after hydrolysis, it will form this. So this is going to your main product. But here they have done 1 4 addition. Question, it is asking wrong main product. So this is your wrong main product. So option A is correct. Let's see another option. Okay, base is given. Base is going to abstract proton from here. It will become anionic nucleophile and it will add in 1 2 fashion or 1 4 fashion. 1 4 I think. So this is your correct product. So therefore this can't be your correct option. Correct? Let me draw for you. You can write NO2 like this. Correct? It will form like correct or not? And at last, after workup and protonation, it will become correct. Now, so B option is eliminated. A option is correct till now. Now let's see here. Here, this is going. This is your enamine, right? It will attack here. So what product it will form? Come here for this. You will get your correct, and here negative charge will come. I hope you are getting. So at last it will form This imine, this is an imine, okay? Iminium ion, sorry. I'm pronouncing it wrong. After hydrolysis, this form ketone, and this is going to attack here, and you will get this. So this is your correct product, okay? And for D, there is less space. Let me erase some part, okay? So let's draw D. So basically, this is a famous example for Robinson annulation. In last problem session, I have also done this question. So let me give you hint for this. Here you have proton. Okay. What? Let me draw myself. This carbon ion. Okay, carbon ion. Correct. This will get protonated. So you will get this moiety. Now this becomes your acidic proton, and how much numbering form? One, 2, 3, 4, 5, 6. Okay, so it will attack here and you will get correct, and at last it will abstract proton from here and result in elimination of water molecule. Correct. So this you, and this is your famous. I don't know correctly, but I think Wieland ketone. Okay. So next name reaction for this session is Robinson annulation. So what is your Robinson annulation? If you look at there, you have alpha beta unsaturated ketone. You have another ketone. So basically, when when Michael reaction is happening intramolecularly. Let me repeat. You can call it by another name, that is intramolecular Michael reaction. Correct? So let's see mechanism. You can read here. I have kept it as notes. First, base is there. Base will abstract proton adjacent to carbonyl, as this is most acidic. Correct? Or we can say that base is abstracted alpha proton. It is formed enolate. This after enolate formation, here carbon ion will form and it will attack in 1,4 fashion. After Michael addition, you have got this entity, correct? And this O negative will go back. Here carbon ion will come and it will get protonated in next step, correct? And it will form this 1,5 diketone Michael product, correct? Now see, there is you by looking at structure you make you see that there are various possibilities for further reaction. So base is there in medium. Base is going to abstract proton. It can abstract from left side, it can abstract from right side also. Let's say it has abstracted from here, will form enolate, and then this enolate is Enolate is going to attack in intramolecular fashion. Intra, intra attack. Okay. Basically, this is aldol reaction, but intramolecularly fashion. So then this will get protonated, and at last, after elimination, you will get this alpha beta unsaturated product. I hope I am clear to you all. So let me revise, or let me again repeat this for you. So basically, a Robinson annulation is nothing but your Michael addition. But here, in Robinson annulation, reacting partners are one of your partner or Michael donor is your ketone, and Michael acceptor is your alpha beta unsaturated ketone. In presence of acid or base, there are different mechanism possible. Okay, so first step is, let me use pointer here. So first step is abstraction of proton by this base, formation of enolate. 1,4 attack on this alpha beta unsaturated system resulted in formation of this, which after protonation gets converted into 1,5 diketone, which is known as Michael adduct. Now still there are possibility for abstraction of this proton, and it will attack on this carbonyl in intramolecular fashion. Correct? So it will form this type of moiety cyclohexanone, and in presence of base it will eliminate water molecule and will result into formation of this substituted cyclohexanone. I hope I'm clear to all. So based on this, problem number 5. Which of the following compounds not the product of Robinson annulation? Let's look at structural features of Robinson annulation reaction. Okay. So let me use pointer for that. So if you look at this part you got this part from your ketone moiety, and this remaining part is your alpha beta unsaturated system. Correct? And in question it is asking which can't be your product of a Robinson annulation reaction. Can this five membered ring product can be annulation product? Right now we have seen na, that six member ring gets formed here. Moreover, another structural feature we can see that this is your R7, R8, R6. This moiety. Okay. So basically, you can see that six-member cyclohexane system is product of Robinson annulation. So this can't be possible. Therefore, this is correct because it is asking not the product of Robinson annulation. Problem number 6. What are the products of the following synthesis? Hint for this question is second reagent is Wittig. If you have RCHO, it just convert your carbonyl to methylene group. Okay. So now try. Pause the video for zero point 0.5 minute or 1 minute and then see. First, let us draw product. Okay. This is your Michael donor. This is your Michael acceptor. I have drawn correctly na? And this is your okay. So we know that enolate will form. It can form from either side because both side there is ketone only. Carbon ion will come here. It is going to attack in 1,4 fashion, and we will get. Let me draw. Correct. Negative charge will come back, and it will proton. Correct. Now Robinson annihilation reaction. Remember, one, two, three, four, five, six. Six-membered ring will form. I hope you all have understood how I have made this product. And after heat, since heating conditions are there, it will form this product. Correct, students? But one thing you can observe, or I can say, one, two, three, four. Okay. So one of the possible product is this. In which option you can see this? Let me redraw this product. So everything is clear till here, guys, students. Correct? Now can anyone tell me other possibility? So basically one of the possible product is this. Okay. So there are two ketones. So after we take reaction they will form this CH2. So sorry for this. So just find this option. Let me form that converted product. So your alpha beta unsaturated wait this. Let's draw by this, na? Okay, alpha beta unsaturated this, and just next to it there is one isopropanol unit. Alpha beta unsaturated and just no. Alpha beta unsaturated. I hope we have made this correctly. As there are other option also, like it can dehydrate from this side also. So let's draw that product. So whenever you are solving these type of question, draw every possibility and then check the most stable. If we draw this, it will become CH2, CH2. Now search for this option. This one, no. This one, see, you can easily eliminate this option, I think. Okay, this is your CH2. Let me erase this and then come to product. Let's resolve this question one by one with all the possibilities keeping in mind. Okay, this will get protonated. Okay, now this can form another ring from both the sides. How much number ring will form? One, 2, 3, 4, 5, 6. Let's see. So basically, CO. I think at last time we missed this CH3 on which carbon we are attacking now. We missed this CH3. That's why we were getting wrong answer, I think. So yes, we will get this. Correct na? 1, 2, 3, 4, 5, 6, and that 6, let me give number, why to get confused. 1, 2, 3, 4, 5, 6, and it will form this. So this is your main product. Okay, so it is given that they are given doing its Wittig reaction, so that will convert a carbonyl into CH2 units. Now this is most appropriate according to me, and I think it last time also we have formed the same product. Just search. I think there is some problem with options. I have to recheck. Let's first check this. Okay, then this is going to form. Actually, it can in this type of system can isomerize also. Sorry, CH2. It can form here, here, and here. This can be like this also. Okay, so let's search A and B. This option is wrong because in one of the product six member will form for sure. Let's do one by one. From here, alpha beta unsaturated system. Okay, here you are getting alpha beta unsaturated system. Okay, right side there. Not compound A is not there. Now let's find compound B. Yes. In compound C, you can see this option. So one of the option we got easily, correct? And another is the same, na? See, in both the cases, they have just got isomerized, correct? We have found so option number C is your most appropriate answer. So see, I am doing all this question also for first time along with you students. So whenever you get problem like this, first draw all the possibilities, correct? Since base is given, since base is given, base can abstract proton from here and it can isomerize actually. So these both the products are possible. Therefore, option C is more appropriate. And another thing is there is no possibility for formation of five member ring because if you form from this side also, you will get 1, 2, 3, 4, 5, 6. So both side you will get six member ring only. So I hope I am clear to all. Next name reaction is your Stork enamine reaction. So first thing is what is actually need for this enamine. Okay. So it has been found in literature that lithium enolates. Note, let me write in notes. Lithium enolates of aldehyde and ketone are not much stable. They get dimerized. Okay. To avoid this problem, Stork has come with his enamine for alkylation, acylation, and conjugate addition. So, first thing is how you are going to form enamine. So, H plus is going to protonate your carbonate. It will increase its acidity. Then, enol will form, and that enol will undergo this attack by this nitrogen nucleophile, and it will form your enamine. Whatever I have said, let me draw here. So, first step is your activation of carbonate, correct? Which will undergo formation of enol. Enol will come back. Sorry, I have done something wrong. This has actually H plus has increased its electrophilicity. Correct? H plus is there, it will protonate this, nitrogen lone pair will come here and knock off this H2. And at first it will form iminium ion. And then this will abstract proton from here and will result into formation of this enamine. Now this is best nucleophile for alkyls. See, if you are giving this type of alkyl halides, it will attack here, knock off this X negative, form iminium. Iminium on hydrolysis get converted into ketone. If you are giving this electrophile, or we can say that aldehyde, it will attack. Okay. OH. I think here it has done substitution reaction and it will form this. And in last example, it simply has done 1,4 addition will result into formation of this. This iminium will undergo hydrolysis and will result into formation of this ketone. Problem number 7. Which of the following among A to D is least likely as an intermediate or a product in the following reaction? So, just few minutes before I have told you mechanism of this problem. Just try. Among all these species, which is most uh, which atom is going to abstract this proton? Obviously, this carbonyl. So first, get activate. This carbonyl gets activated in presence of proton. Then this nitrogen nucleophile is going to attack here. Correct, and it will become positive. Correct or not? Remember, it is having hydrogen here. Okay. Now, intramolecular proton transfer reaction. Nitrogen lone pair will go and knock off molecule of H2. Correct? So one of the intermediate is this, one intermediate this, one is this. And at last what happened? Formation of enamine takes place. So option number A, let's see. Least likely intermediate. This, so we have got enamine, we got among A and D, which is least likely. See, this is possible, you know, it just attacked, okay, but both here, this nucleophile can't be on both the on this carbon. It can't substitute in bifunctional way, okay. So option D is least likely to form. So next name reaction for today's session is Noe-Vinegal condensation reaction. Basically, in Noe-Vinegal condensation, we have active methylene and another reactive carbonyl. Ester may be there, aldehyde is there, or ketone may be there. Okay. So let's have a look at its mechanism. Base is there in our reaction medium. Base is going to abstract proton from this active methylene, will result into formation of this enolate. Okay. This enolate can have these three iso resonance forms. Correct? Till now, I think everyone is clear. So, in Noy-Vinegar condensation is first step is your formation of enolate from your active methylene group. Okay. Another instance, it is given that one of the amine base is there. For example, in mechanism, they have used piperidine. So, this base is nothing but your piperidine. This is going to attack your carbonyl carbon. Okay, N positive will come. This intramolecular proton transfer, correct, and will result into formation of this iminium. Now this enolate which has been formed in first step, it is going to attack your iminium ion. Okay, in this way. Piperidine is there, which can also act as base. It will abstract proton from here. We will knock off this and will form this highly conjugated system. And this is your mechanism for Neue-Vinegal condensation reaction. Can I repeat? So first step is formation. So first step is formation of enolate from your active methylene. And in second step your aldehyde is going to form, or is your aldehyde is aldehyde or ketone, whatever it is given, it will be activated. How? In presence of nitrogen base. In presence of nitrogen base, iminium ion will form, and then that iminium ion will get attacked by formed enolate in first step, and will result into the formation of this alpha beta unsaturated system. This is your Neue-Vinegar condensation reaction. I hope I am clear. So, problem number 8, it is based on your memorizing power. Match the example in column 1 with the name of reaction in column 2. In my first or second session, wait, I have told you this is famous reaction, that is Rosenmund. Rosenmund. We can call it Rosenmund reduction also. Rosenmund reduction, since there is addition of hydrogen. Okay, this is poison, this is just to poison. This has been used here as a poison just to decrease the activity. This is your famous, tell me, Friedel-Crafts acylation. So let's match. Since electrophile is substituting proton, it is electrophilic aromatic substitution, famously called as Friedel-Crafts acylation. I hope you remember mechanism of this. First, this acyl chloride in presence of Lewis acid such as AlCl3 is going to form acylium ion, that is CH3CO positive, active electrophile, and it is going to attack your benzene ring, correct? This is, I think you all know, this is famous aldol reaction. And this alpha bromo, it's Hell, Volhard, Zelinsky reaction for forming alpha haloacyl. You should remember all the name reactions. So problem number 9, you have to tell main product of this reaction. You can see that this is example of intramolecular Claisen condensation. Correct? Base is going to abstract proton from here. 1, 2, 3, 4, 5. 5 member ring will form. Correct? Just do numbering here also to avoid all the confusions. At one number, CO2 ET group is attached. 2, 3, 4 are single, and 5 you will get O negative, OET. O negative will come back, OET will knock off. Remember one thing, this mechanism I am writing here just for understanding purpose. You should know that all the steps in collision condensation are reversible. Okay. And take home message or note from the slide is there should one proton which can be abstracted by this OET negative. Otherwise, this reaction is highly reversible. You will not get this product. Okay. So correct product is this. Answer number A is correct. Problem number 10. Rank the following carbonyl compounds in order of acidity. I have told you earlier that active methylene are most acidic than your aldehyde or ketone. In active methylene, both side ketone are much better than both one side ketone ester or ester ester. So correct option is this one, 2, 3, 4. Okay. So most acidic is 2, then 3, then your 4, then your 1. Remember, this is your most acidic. And if you want to know that why it is most acidic, so let's see here. See, who have more advantage of having carbonyl here? This one or this one? This carbonyl is relatively, its electron deficiency has decreased by this OET group because overall OET is plus M group, correct? But in ketone there is no such stabilizing factor other than your hyperconjugation, if you call that. Therefore, ketones are more acidic than your esters. Remember this thing always. So this is first tell me what is acetoacetic ester. Acetoacetic acetoacetic ester. This is your acetoacetic ester. Correct? In first step, it is undergoing NaOH is there, so it will go. Tell me, base is there, students. Since there is no other component given, let's make it dimerized product. Carbanion will form here, and if we look at another molecule, definitely it is going to attack ketone part, not your ester part. Correct? So what we will get? CH3, CO, carbanion, CO2 ET, O negative, CH3, CO2 ET, and it will take proton from your H plus. Correct? Since we have done mistake here, we can protonate if in further step nothing is given. Correct? But in next step we are given CH3 ion. This negative charge is going to attack here, knock off this iodine, and at last what you will get? CH3, CO, CO2 ET, OCH3, O alkylation. Everyone is clear till here. Now another base is given. Base can abstract proton from this side. One, two, three, four. You have to see this I am keeping as your homework. Okay. First step is you have to draw it in next class. First we will discuss this, then we will move ahead. Okay. So you have your acetoacetic ester. In first step, do self dimerization reaction. Then your methyl iodides are there. So do its reaction. Another step there is given, another alkylation. So do one more alkylation. So do one more reaction, and then whatever carbon ion you are forming, extract it with alkyl halide. Just try this. If you are unable to solve, I will tell you in next class. Okay. So tell me the major product of this reaction. If we write it like this, correct? We know that it will form carbon ion here, correct? It is going to attack this. Now what will happen? Actually, problem number 12 and problem number 20 are almost similar. So you try both the question by yourself. Correct? And we will discuss solution of problem number 11 and problem number 12 in next problem solving session. Thank you. So thank you students.